Hey guys, welcome back to our channel. In today's lesson, we will be learning about same-side interior angles. Make sure you are taking good notes on whatever you feel hesitant about. And if you haven't already, I would highly recommend reviewing corresponding alternate exterior and alternate interior angles where they are used. Let's get started. These are same-side interior angles. As per usual, I will say it's a great idea to draw a diagram like this one into your notes to remember for later in the future. Looking at the diagram, we have our usual parallel lines and transversal. However, same-side interior angles are very different from corresponding and alternate angles because the pairs are not congruent, but instead supplementary. Now I'll be switching between these two papers, but please bear with me because we have a new vocab word. This is our vocab word, supplementary. Supplementary is an extremely commonly used geometric term. Supplementary means either of two angles whose sum is 180 degrees. So you could have an angle measure of 20 and 60 degrees, and that would be supplementary. Or you could have an angle measures of 100 degrees and 80 degrees, and that would be supplementary too. Throughout the rest of this lesson, you will see me abbreviate the word supplementary to sup on the papers. Okay, going back to the previous diagram, we can now see that angles 3 and 5 are supplementary, and angles 4 and 6 are supplementary too. To remember this, just break apart the word same side interior. The supplementary angles are on the same side of the transversal, and they are the inside or interior of the transversal. Let's look at an example here. In this example, you can see we're trying to solve for measures angle 1 and 2. And I will prepare you here. I will be incorporating some past transversal knowledge. So if you have some time, I would highly recommend going back and taking a listen at some of those lessons if you haven't already. Okay, here we have a transversal. We know that the lines are parallel, so we can use one of two strategies. One, we could use same-side interior angles, which we just learned. Or two, we could use alternate interior angles that we learned about back in lesson 4. So, just for explanation purposes, I will be using both strategies in this problem. However, when you come across such a problem, you can always just use one strategy. Okay, to solve for angle 1, we'll use the same side interior angles. So we can set up our equation. We're given that this angle up here is 50 degrees, so we can say 50 plus angle 1 has to be equal to 180. Now we can subtract 50 from both sides, so that way we can cancel out the 50, leaving our answer as angle 1 being 130 degrees. Okay, so now I hope you're able to notice that we can use alternate interior angles to find the measure of angle 2. And since we already know that the interior angle is 50 degrees, that we can just say that angle 2 is 50 degrees, alternate interior. Okay, let's move on to the converse of this theorem. If you have been following along with the rest of my transversal videos, you may be able to pause this video and guess what the converse of the same side interior angle theorem is. But let's first put the original theorem in words. The theorem states, if two parallel lines are cut by a transversal, then the two pairs of the same side interior angles are supplementary. And the converse states, when we flip the two subjects, if two coplanar lines are cut by a transversal so that a pair of same side interior angles are supplementary, then the two lines are parallel. Here's a quick example. We are given that angles 1 and 2 are supplementary, and we have to prove the lines L and M are parallel. I want you to pause this video and try to put together a sentence or sentences that prove why L and M are parallel. Okay, so here's the answer. Even if you framed it differently, that's okay as long as the content of it is similar to what we're gonna listen to. Here it is. Lines L and M are parallel because of the converse of the same side interior angles theorem. We know that angles 1 and 2 are supplementary, so therefore we know the lines are parallel. Hopefully you understood that. And I hope you learned something new or reviewed something old during the course of this video. This is just one video in a series where we discuss different angles you'll see in transversals. Until then, make sure you write down some of these vocab words and their definitions to reference for later. Thank you so much for watching this video. To get more content like this, make sure to subscribe and hit the notification bell. And if you perhaps enjoyed it, please give this video a thumbs up and share so we can help even more people. It also really helps our channel grow. So until next time.